a container holds 7/10 liters of oil and vinegar. 3/4 of the mixture is vinegar. How many liters of vinegar are in the container? Express your answer as both a fraction and a decimal. See, it'll tell you in the question how it wants you to put the answer. So here it's telling you that it has the entire container has 7/10 liters of oil and vinegar. If 3/4 in the mixture is vinegar, what is this part of the mixture right here? It's what? It's oil. I mean, it tells us it's oil and vinegar. So we've got vinegar and oil. How many liters of vinegar are in the container? So we have to do what would we do to figure out how many liters of vinegar are in the container? What would we do to solve that problem? Okay, so I don't know if you heard it, but she said make 3/4 a decimal and multiply it by 7/10. Because what you can't do is a fraction times a decimal. You've got two different forms. You can't do them together. So you either have to change this to a fraction or this to a decimal. Okay? Now, I'm going to show you an even easier way. Okay? Say this. Say it. It's not 7. What is it? 7/10. How do you think you write that as a fraction? 7 over 10. 7/10. 7/10. That's why I rode you so hard about saying your decimals correctly. How you say it is how you write it. 7/10. So 3/4 of 7/10. So now you can go ahead and bam, get your fraction form out. 3/4 of 7/10. And what do you get? 21/40 of a liter. Okay. Now we need to turn that into a decimal. So, and you're like, how on earth are we going to do that? So it actually is. So 21/40 times something to get to a power of 10. Can 40 get to 10? No. Can 40 get to 100? So now we know that 4, what do we know about 4? 4 can go to 100. Now we're not doing 4, we're doing 40.
So it's the same thing, just adding zeros.
Right. I don't know if you can hear Tamaya again. She's talking really soft. She's not big mouth like me. So it's the same thing. It's just an extra 0 on the back. So if 4 can get to 100, 40 can get to 1,000. 25 times. Ah, just like 2 and 20, same thing. So 25 times. See, you guys are smart. I knew it. So now you just got to multiply 21 times 25. Oh man, 2-digit multiplication. We've never learned that before. What is 21 times 25?
25.
525. 1 times 5 is 5. 1 times 2 is 2. 2 times 5 is 10. 2 times 2 is 4 plus 1 is 5. Decimal back there. 1, 2, 3. 525,000 of a liter. Andre completed a 5-kilometer race in 13 and a half minutes. His sister's time was 1.5 times longer than his time. How long in minutes did it take his sister to run the race? So, does it matter that it's 5 kilometers? No, they're not asking you how long was the race. They're not asking you how long did she run. None of that. They're just saying that he ran it in 13 and a half minutes. They're saying her time was 1.5 times longer. How long in minutes did it take his sister to run the race? I want to see if you can figure this one out without me. See if you can figure it out. Now, this is a strategy. You don't have to use it, but this is like a little visual. If Andre, whatever happened to Andre? If Andre ran it in 13 and 5/10, this is Andre. This is Andre's bar. Okay? That's what he ran. I'm not splitting him up. I'm not dividing him. They didn't say anything that he broke it up or anything. Zanaya, I'm up here. His sister's time was 1.5 times longer, which means if I did a bar for his sister would be the exact same length. Sister. So that would be 13 and a half plus a half a bar more. So I need to figure out what 1/2 of 13 and 5/10 is. That's how another way to do bar modeling. We did that. When I say we, I don't mean you, because I don't know if you did this in 2nd grade, but one of the years that I was in 2nd grade, we really, really did bar modeling and hit it hard. We did it big time. So if you've got 1.5, that means you've got one part where they're the same and then half where they're more. So 1 and then a half. So 13 and 5/10 times 5/10. So that's 25, 2, 15, 17, 6. 1 decimal, 1 decimal, 2, 1, 2. So 6, 7, 5. So now I've got to do is add 13 and 5/10 plus 6 and 75/100. And that will give me hers right there. Now, yes, you could have also 13 and 5/10 times this. But you have to be aware that this is this. You have to be aware to be able to turn that into a decimal. Or you have to be able to turn this into this. And, you know, there are a lot of things that you have to be able to do. So 13 and 5/10 plus 6 and 75/100. 5, 2, 1, 9, 0, 20 and 25/100. minutes. So if you have figured out so far that 1½ is the same thing as 1 5/10, because we've done that one several times, yeah, you could have saved yourself some time and just multiplied this times this, and you would have got the same thing.
How do you get the 5 or 1?
5/10 is always 1/2. You are welcome. 5/10 is always equal to 1/2. Good. A clothing factory uses 1,000. You know, this is a comma, not a decimal. 1,275 meters of cloth a week to make shirts. How much cloth is needed to make 3 3/5 times as many shirts? Wow. So 3 3/5. So now they make this. They want to make, so this is their goal. This with another one. So 1, 2, 3, and then 3/5 more. Just bar modeling. You don't have to do it this way. I ran out of room. How much cloth is needed? The easiest way to do it. The easiest way to do it. You want to see the easiest way to do it? Sure. You've got a decimal here, right?
Yeah.
Turn that into a decimal. All right, so you've got the 3 and you've got 3/5. So for right now, I know that my big 3 goes in front of the decimal because it's 3 and. 3/5 I need to put behind the decimal. I just need to figure out where it goes behind the decimal. So 3/5 times something becoming a power of 10. 5 goes to what power of 10? 10. So times 2 times 2. 3 times 2, 6. So it becomes 6/10. 3 6/10. So, yes, you good? So, this becomes 3 6/10 times as many. So, 7, 5 2/10 times 3 6/10. Good? Then if you didn't get this, then you just messed up somewhere in your multiplication. So 6 times 2 is 12, 31, 42, 45, 12, 16, 7. Add a row, add a 0, 6, 15, 21, 22, 6, 8, 3.
Okay, I'm not adding addition. Is my addition.
2, 7, 0, 9, 5,
Oh,
4.
I said 6 plus 1 is 6.
OMG. Then I've got 1 and 1, which is 2, right there. So that is the easiest way to solve that problem. The other one with the bar modeling was a lot more complicated, where you had 3/5. They did 3 times this number and then 3/5. I've never seen where you've done a decimal and a fraction in the same problem. I've never seen that before. I've never seen it. I didn't know you could do that. So, anyway. There are 3/4 as many boys as girls in a class of 5th graders. If there are 35 students in the class, how many are girls? And you would not believe, if this is a test question, the number of fraction people I will get. Because we're going to Texas Chainsaw Massacre again. Well, I get half people. We're committing felonies in here again. Or I'll get like 60 girls when we only have 35 students. We'll have more than the people that we have. So you can't have fraction people, and you can't have more girls than there are students. So that's, again, checking to see if your answer is reasonable. So if there are 3/4 as many boys as girls in a class of 5th graders, and there are 35 students in the class, how many are girls? This one you do need a tape diagram. Okay, so if this is girls, and we have, 3/4 as many boys as girls. Boys is 1, 2, 3. Girls has 4. Boys only get 3. 3/4 as many boys as girls. Boys get 1, 2, 3. Out of the 4 that the girls get. This is a very weird tape diagram. I have to stare at it a couple times myself. I know. So 3/4 as many boys as girls, because 1, 2, 3 out of the 4 that the girls have.
Wait. So it's not 1/4.
3/4 as many boys as the girls. If there are a total of 35 students.
Oh, 5. Yay.
How many are girls? It's not 5. How many are girls? Why is it 20?
Because 5 times 4 is 20.
Because each unit would be 5.
No. That would be 15 boys. I don't understand.
It is a very odd way to solve it, but that is the only way I can see to solve it.
Why would they word it like that? Because they wanted to say it. Yeah.
3 units are boys, 4 units are girls, since they're, it's even just worded on here. So an artist builds a sculpture out of metal and wood that weighs 14 9/10 kilograms. 3/4 of its weight is metal and the rest is wood. How much does the wood part of the sculpture weigh? I've had countless students in the past use this. 3/4 is metal. The question is asking about wood. How much of the sculpture is wood? 1/4. So 3/4 is metal. That leaves 1/4 is wood. That's what they want. 1/4 of 14 9/10. So you could turn 1/4 into a decimal. So won't go to 10, but it can go to 100. Ah, 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 ah. 45, 20, 24, 7, 18, 9, 6, 12, 17. I don't know, that's why I just said that's not right. Alright, doing it again. 20. See, that's what I did it. I said that answer is not reasonable, so I'm doing it again. Some people, they don't check to make sure their answer is reasonable, and they just throw it on there. 20, 24. 7. 18. 8, 9. I did something really wrong. I don't even know what it was. 12, 1, 17, 4. Oh, because I didn't move my decimal in front of 1, 3. 1, 2, 3.
So you had it right.
I had it right. I didn't do my decimal. 4 and pounds. Kilograms. So each unit is that. So if you think about, if I have children, that's 1/2, right? So 1 unit out of how many? 2. So I would have 1 unit. So there are half as many children as there are adults. It's like the boys and girls in the class out of what? How many? How many kids there were in that class? 35 kids. Okay, so then we do the adults. 1 is half of what number? 2. There were half as many children as there are adults. For a total of 30. So there are 3 total units. How many in each unit? 10. How many children are there? 10. How many adults are there? 20. So it can't be 15. See, when you do the visual like that, it makes it a whole lot easier. You can't just go half of 30 is 15. It doesn't work out mathematically that way. Sometimes you have to do a model to make it work out. You have to work backwards. Is it always easy? No. It's not easy. It took me a long time to go, oh, I feel dumb. It took me a while.
What, so you did it at home?
Huh?
It's like you do this before reading.
Sometimes. Half as many children as there are adults. So you have to look at this as how many children are there? One half. 1 out of 2. So there are double the adults. So you just have to figure out a way to work that out. Do I like these problems? No. But these are the types of problems that are supposed to make you, and I hate this term, think outside the box. They're supposed to make you stretch your thinking. Not all math problems are, I have 5, I got 4 more. How many do I have now?
9.
They're not always going to be that simple and in your face. So sometimes you do have to kind of stretch your thinking. So.